All right, so question number 4, competitive equilibrium. So we're given the market demand curve for good X. It's a function of both the goods price, good X's price, and I, which is just an exogenous income parameter. Obviously, as the consumers get more income, they demand more of the good. As the price increases, they demand less of the good. There's costless entry and exit for the industry that produces good X, and you observe H firms at a long-run competitive equilibrium. All firms produce little x with the cost function represented right here. C of x is equal to ax squared plus bx plus d. How much does each firm produce? So in long-run equilibrium in a perfectly competitive market, we know, here, let's write these things out. So this is question 4, competitive equilibrium. I'm going to write out all the information we're given here. So we have the quantity demanded, which is 100 plus P minus I. Costless entry and exit. Here's our cost function. The total cost function is C of x is equal to ax squared plus bx plus d. And we know that in the long run, competitive equilibrium with costless entry and exit, each firm is going to be making zero economic profits. So we know that the profit's going to be equal to 0, which means also another feature of the long run competitive equilibrium is that the price is going to be equal to marginal cost, which is equal to average cost. So we can solve for how much each firm's making by taking this total cost function, deriving the marginal cost and average cost functions, and then solving for x. So that's exactly what we're going to do, right? We're going to take the marginal cost function, which is 2ax plus b, right? Just take the partial derivative with respect to x, the average cost function, which is just the total cost function, divided by x here, right? So we can set these two equal to each other and solve for x. It's going to involve a little bit of algebra, so bear with me here as I work through it. Equals ax squared plus bx plus I all over x. Let's see, what's the best way to solve this? Let's start by multiplying both sides by x. Why not? This is probably not the best way to solve it, but it's the first thing that occurs to me. Ax squared plus bx plus I. Okay. 2ax squared. Subtract an ax squared. To get this over here, we can just remove the bx's too. So that's going to be ax squared. Oh, I forgot. That's not I, that's d, right? I'm sorry. Let's fix that. Okay, so we got rid of this guy. We got rid of this guy by subtracting, and then we got rid of that. Ax squared equals d. Divide both sides by a, which gives us x squared equals d over a. Square root of both sides gives us x square root of d over a. This is how much each firm is making in that long run equilibrium, right? All right, so let's move on to the next question. What is the market price for good X? So, what's the market price for good X? That's what we're trying to figure out. Well, again, we know that price equal to average cost equals to marginal cost in the long run equilibrium for the perfectly competitive market. So we want to figure out what P star is. We can just set it equal to marginal cost. So marginal cost was 2ax plus b. 2ax plus b. And we know how much they're producing at the profit maximizing. We know what the profit maximizing quantity is that they're producing, right, in this long run equilibrium. So we can just go ahead and plug that in. So we're going to plug in x star square root of d over a plus b. And then we can simplify this, make it a little bit easier to work with. This is a to the 1. This is a to the negative 1/2. You add the terms when you multiply them. So you get a to the 1/2 So we can just put it in here, plus B. This should be our equilibrium price. Let me double check, make sure I didn't make any math mistakes. And through some miracle, I did not. Cool. So we know what the market price is for the good. Solve for H. How many firms are in the market, right? Let's go back over here, pick a new color. 4.3. We're trying to figure out what's H. What does H equal? Well, in the perfectly competitive market in equilibrium, we know that supply is going to be equal to demand. We know what the demand function is from up here, 100 plus P minus I. 100 plus P minus I. And what's this S term? What's the total supply? Well, it's going to be the number of firms times how much each individual firm supplies. And we know we've already solved for what the profit maximizing quantity is for each firm as a function of these exogenous parameters. So we can go ahead and plug that in too. This is equal to H times, what was it, square root of D over A. Square root of D over A. All right, and then we just have to solve for price. Or excuse me, we're not solving for price. We're solving for H. Should we plug in P? Yeah, we probably would plug in P because we've solved for P star too. We really want to get this function here. We want to create a function of H that's just the exogenous parameters. So let's plug in P as well. So I'm going to move H over here to the other side. Ugh, I don't want that. I want D over A. This is how much each firm produces. This is how many firms there are. That must equal to 100 plus P star, which is 2 square root of dA plus B minus income. So now we have this function that's only exogenous parameters, and we want to solve for H. And we can just multiply both sides by the square root of D over A. And so if we do that, I'm going to be a little hand wavy with the math here to save you guys time. Well, save me time too. Times A over D, not over D, A times D minus B plus I times the square root of A over D. This will be our solution, telling us how many firms are in the market as a function of the exogenous parameters A, B, D, and I. All right, you observe an increase in I. C of X does not change, so the cost functions don't change. So one thing that we know about this is that this must be a constant cost industry. In the long run, what must adjust so that the market clears? Well, let's clear this out. So what we're seeing graphically in 4.4 is that we have a supply curve and we have our demand curve of price and quantity. And so we have this shift in the demand curve caused by this increase in income. So we're moving from D sub 0 to D sub 1, and we know that market quantity has to increase, right? So the total market quantity has to get larger, right? Because we're moving from Q sub 0 to Q sub 1, so there's this change in Q. And we know that the total quantity supplied in the market is the function of H times little q star. And q star is not going to change because the cost functions aren't changing. So they're still setting price equals to marginal cost, and marginal cost isn't changing. So what we're going to see is, okay, I drew this wrong, right? I drew this should be the long run supply curve, and it's going to be totally flat. So I guess I could erase it, but just know in this instance, this is a perfectly elastic long run supply curve. I mean, here, actually, you know what? This is probably a useful illustration. So this is the short run supply curve. Can I go back to my other color? Probably not the same color. This is our short run supply curve. So this would explain like price would change in the short run because these firms would travel up their marginal cost curves, right? Then they would start enjoying economic profits. So price in the short run would go back, would increase to P sub 1, and we'd get the same level of quantity supplied, but these firms would just have economic profits, right? Their marginal cost curve, all their cost curves are the same, but they're getting a higher price for the goods. So the marginal cost is equal to marginal price, but that's no longer equal to average cost. Average cost is lower than the price and the marginal cost of producing the good. So they'd be enjoying some economic profits in the short run, but then the long run equilibrium would adjust. So the short run supply curve would actually shift from here to here. And that's where we get that's how we derive this constant cost industry long run supply curve, where price is just going to go back down. And the only the mechanism through which this occurs, yeah, this worked out better than I thought. I'm glad I made that mistake. Is that, well, hey, Q star is going to go back down to whatever it was before because marginal costs are unchanged. So H must increase. And this is a very long-winded way of explaining that, just because I wanted to take this opportunity to illustrate what's happening in the market through the short run to the long run. But because those cost curves aren't changing, it's a constant cost industry. Well, that short run supply curve is just going to be shifted out to the right from firm entry, but their cost structure is the same. And so the long run supply curve totally flat, which we know because the cost didn't change, and we get this new quantity and the same price as before. All right.